The next three learning targets are about hyperbolas. You guys have your note sheet, so you know what a hyperbola looks like because it's on the front. All right? There's horizontal hyperbolas. There's vertical hyperbolas. All the stuff with hyperbolas is super similar to ellipses. So, with that being said, if you didn't know what to do with the ellipses, we need to figure it out for hyperbolas. Now, when I talked about ellipses, I set up a lot of things in the beginning, gave you lots of definitions. And some of you guys wouldn't commit those to memory, so you didn't know what A was, or didn't know what B stood for, or didn't know what C was. That made it hard to answer some of the questions. Similar ideas here. You have to commit these definitions or these ideas to memory so you know what you're talking about when you go to do the problems. All right. A hyperbola is a set of all points in the plane in which the difference of the distances from two distinct fixed points called foci is constant. Think back to that animation I showed you about ellipses, right? Gave you an animation and I said there was these two foci and there was a point on the ellipse. And it drew the ellipse and it had the distance from each focus to that point, and when you added them up it was always the same. Like the sum never changed. This would be the same animation, except that the difference would always be the same. So they'd be subtracting those distances, not adding them. That, again, is why we have the foci, so that we have a formal definition of what we're doing. They aren't actually part of the graph. The center of a hyperbola is the midpoint of the line segment whose endpoints are the foci. So you have, again, you have this picture already on your notes. You have two foci. You have an imaginary line going through them. You have a center in the middle, which is still HK. In this case, the center isn't actually in the middle of the circle, in the middle of the ellipse, because the hyperbola is two arcs or two parabola shapes. So it's in the center of those two shapes. It's not actually like enclosed in something. The point on each branch of the hyperbola that is nearest the center is called the vertex. So if we have two arcs here for our hyperbola, they actually go through the vertices. Those vertices are on that same line as the foci in the center. You only have two vertices, not four. So that should be less to keep track of. There are two asymptotes for our hyperbola. We talked about asymptotes earlier this year. Those are imaginary lines. They kind of give you boundaries. So we have two imaginary lines that go through the center that give you boundaries for the hyperbola. So the hyperbola will get closer and closer to those lines but never cross them. And the hyperbola has two axes of symmetry, just like an ellipse. You have the transverse axis. It's from vertex to vertex. It has a length of 2a. That means A is still the same here. A is from the center to a vertex. C is to the center to a focus. So C would be this distance right here. Still the same. We also have a conjugate axis, which is drawn to the center and is perpendicular to the transverse axis. It has a length of 2b units. In this case, A does not have to be greater than B. So there are going to be some things about ellipses that you are going to confuse with hyperbolas if you don't kind of keep things straight and don't use those formula sheets. Any questions about what any of those pieces are? We're going to be graphing them today, so you have to know those pieces. All right, so the first thing we're going to do is go through and fill out the information for horizontal hyperbolas and vertical hyperbolas. Again, I've highlighted what's on the yellow sheet or the red sheet for you for the formula sheet. You need to be using that so you know what you're using and what's available to you on the quiz. So you have a horizontal horizontal hyperbola. You have an equation that's very similar to an ellipse equation, but it's not the same, and we'll talk about that in a second. You have an equation to find C that is very similar to what we had with ellipses, but it's not the same. What your foci and vertices are. Again, what's highlighted is what's given to you, and what's not highlighted you need to know.
one where the square has x on them.
It's just like with an ellipses. There was a standard form of the equation, which is the top version. And then there was an equation that tells you how to find C, and that's the bottom equation. They're completely separate. Those are on the next slide. I'll get to those in a second. That's a whole other chart.
Wait, so what's this point? Is this vertical or?
The first one's horizontal, because if you have the hyperbola, it's going side to side. It's side to side. All right, and then you have vertical ones, which again, very similar. You need to make sure you know how to find them, but they're not on the red sheet. Yeah, but there's not minor ones here, so. Less stuff. Well, we have to find the equations of the asymptotes, though, so it kind of equals out. It does it right here. Yes, they have foci. Have to have foci, or there wouldn't be a hyperbola. So some major differences you need to take note of. 1, A does not have to be greater than B. A and B have nothing to do with how to tell what the orientation is anymore.
Right.
There's a minus sign in the middle of both of these equations. If they're in this order with the minus sign in the middle. If X is in the front, it's horizontal. And if Y is in the front, it's vertical. Order is going to matter now that there's a minus sign. So A squared is always under that fraction that's in the front as long as the minus sign's in the middle. I keep saying that because you could rewrite it. I'll do that in a second, show you what I mean. But in general, whatever's first, that's A, and second fraction's B. So order matters. Questions about that? Some of you guys kept doing this on the last test anyway, so this should be great for you. C squared equals A squared plus B squared in this case. It was A squared minus B squared for ellipses. So C squared equals A squared plus B squared. You can use that. Any questions so far? You also have the equations of the asymptotes. They're not fancy. They're just written in point slope form. So I wrote point slope form for you here like you learned in Algebra 1 and Geometry and Algebra 2. The one that's highlighted is how you're going to have to find the slope. So I would write that one. You're sassy all the time. They're not the same. Yes. That matters for if it's horizontal or vertical. In Highlights? The magazine? No, in Highlights magazine. Yeah.
There's no difference. Like, not free.
All right. Everyone have all that information written down? Okay. Then in Learning Target 9, just like in circles and ellipse section, we're going to take the standard form or the general form of the equation, and we're going to find all the information, and we're going to graph it.
Why?
We're still practicing the same skills, different conic section, because I said so. All right, I'm going to do, one second. I'm going to do this example, not the first example. You can go back to the first one on your own if you need to practice. Brandon, is your question about math?
Yes. Scott asked you a question. What is one
For this equation, is this horizontal or vertical? Horizontal or vertical? Vertical. Why is it vertical? Why is it in the front? All right. Again, A does not have to be greater than B. We've already established that. So those of you saying that A is bigger than B, you're already wrong. I said that that does not apply anymore. This one is, but that is not a normal general rule. So do not use that rule. It is wrong. Now, I could rewrite this. That's what I was saying earlier. I could rewrite this. And Y wouldn't be in the front anymore, and it would still be vertical. So you have to keep track of where your minus sign is, right? The minus sign should always be in the middle. So if you have the minus sign out front, you need to make sure you swap them so they're in the right order so you can determine what way it's going. Okay? All right, so then we need to find all the stuff. We need to find the center, the foci, the vertices, the equations, the asymptotes, and then graph it. It doesn't take that long. First of all, the center. That should be really easy. What's the center?
3, 2, 3.
2, 3. Be careful. Even though the y is in the front, the 3 is still the k, still the y coordinate. And then we need to know what A and B are so you can do some stuff later. So what is A? 4, and B is 2. All right, this would still be vertical if these were switched. And A would be 2, and B would be 4, and that would be okay. All right. Nothing. All right, so we have the center. We know what A and B are. We're going to find the vertices. There's only 2 of them. Since it's vertical, we have H, K plus or minus A. That's 3 plus or minus 4. Now, let's say you're taking a quiz, and you can't remember that. That's H, K plus or minus A, even though the red sheet tells you the foci is H, K plus or minus C. And I already told you, you just switch those out. But you forgot, and you're having a moment. You have a graph. So you graph 2, 3 as the center. You already know it's vertical, and you know A is 4. Then you should be able to count 4 up and 4 down and find those points and write them out. 1, 2, 3, 4. Oh, that's 2, 7. 1, 2, 3, 4. You have to graph it eventually. That's 2, negative 1. So if you can't remember any other way, you could always just graph them and figure out what those points are by taking the center and adding and subtracting 4 by counting.
And then you go sideways to.
But this is a hyperbola, so there's not vertices there.
But you know, on the other one sideways.
Yes,
Right.
correct. For ellipses, that would work. All right, questions about how to find the vertices, mathematically or from the graph? So we found the vertices. Next thing is the foci. Those are at H, K plus or minus C. Well, I need to know what C is then. And the equation says C squared equals A squared plus B squared. So that's 16 plus 4, which is 20. So C is the square root of 20. You can rationalize that and simplify if you want to. You don't have to. You can leave the square root of 20. Or you can write it as 2 square roots of 5. That's up to you. So we have 2 and then 3 plus or minus the square root of 20. Since we don't have to graph those, you can just leave it that way. Again, this is on the red formula sheet, so there's no reason for you to miss that. Questions about the foci? All right. So the only thing we're missing now is the equations of the asymptotes. So the equations of the asymptotes. We have two different equations. So we have y minus k equals a plus or minus a over b times x minus h, because it's vertical. Correct me if I'm wrong, but I'm pretty sure that's right. So we're going to fill all of that in with the information that we have, and we're going to split it apart and write two equations. We're going to put them both in a slope-intercept form, like you did in Algebra 1 and Geometry and Algebra 2, and then we're going to graph them, like you did in Algebra 1 and Geometry and Algebra 2. So I have y minus 3 equals plus or minus 4 over 2 times the quantity x minus 2. Everyone know where all those numbers came from? All right. So we can simplify this really quickly. Y minus 3 equals plus or minus 2. But now I'm going to split it into two separate equations. There's one that says plus 2 and one that says minus 2. You do not have to show all of the steps if you know what you're doing. I don't want to lose anybody, so I'm going to show all the steps. So we distribute. And then we add 3. Well, that's the last thing you have to find. Any questions about where those two equations came from? And we need to graph them. We need to graph the center and the vertices, which I already did. So if you have not graphed the center and the vertices, make sure you graph the center and the vertices. Then we're going to graph the asymptotes. The asymptotes should go through the center. If they don't go through the center, your asymptotes are wrong. Or your graphing skills are wrong. One of the two. Or both. Good point. So the first one says y equals 2x minus 1. That means you start at negative 1. That's the y-intercept. And the slope is 2, so you go up 2 over 1. See, it goes to the center. I'm sorry. Correct. It goes to the center. Always go to the center. I would go all the way, but that's just me. I know, I have the line tool. No, it's just imaginary. That's why I put it like as. We need to have it so we know how to draw the hyperbola, how skinny or how wide it's supposed to be. The other one is y equals negative 2x plus 7. So we start at 7 on the y-axis, and we go down 2 over 1. Still go through the center. Since it says negative 2x plus 7. That's not always necessarily true. Questions about where the asymptotes came from or how I graphed them? Then the only thing left to do is to actually graph the hyperbolas. You have the vertices. The hyperbola is just two separate parabolas. Goes through the vertex and it gets close to the asymptote, but it never actually crosses it. If you don't have the asymptotes, you wouldn't know how to wide or narrow or it's supposed to be. Yes.
a lot of work to draw.
Sorry. Questions about the hyperbolas? Right here. All right. Then I'm going to do the rest of our trigonometry. I'm going to do the back. I'm going to do the one in standard form, the general form to change the standard form, but I'm not going to find all the stuff and do all the stuff. Yeah.
That one about one question.
Yeah.
So we don't have to
No. You,
about x squared over
you can do that first example if you need more practice. Then don't do it. All right. So here it's asking the same thing, but you have an equation in general form. We're going to put the equation in general form into standard form the same exact way we did in circles and we did ellipses. We complete the square. So if we're looking at this, this is the exact same thing as we did with ellipses, but there's a negative, and you have to be careful of the negative, because if you don't be careful of the negative, you mess it up. So we have y squared minus 5x squared. I should already be able to tell you if it's vertical or horizontal. Is it vertical or horizontal? Vertical, because the y squared comes before the minus sign. So it doesn't matter what form it is, I should be able to tell on this one. Okay? So there is no other y pieces, right? There's just y squared. There's no other terms with a y in it. So we won't need to complete the square for that part. It'll just be y squared. I do need to complete the square for the x's, though. So I have y squared. Now, because there's this minus sign, I'm not just factoring out 5. I'm factoring out negative 5. So be careful with your signs. When we did ellipses, it didn't really matter because we knew we had a plus sign in between, and so a lot of you guys didn't even write that part down when you were completing the square and put it back into the equation. Now it matters. So if I take a negative 5, I have x squared. If I take a negative 5 out of 20x, what do I have?
negative 4.
Right, negative 4x. So that negative is important. And we have equals 50 over here. So then how do I complete the square? How do I get this number right here?
You take negative 4 and divide by 2 and square that.
So we get positive 4.
And you multiply times 50, right by, and then you use 20, and you add that.
Right, so you have negative 20. That's very important. If I was completing the square for the y part, I would have a positive, so I would be adding and then subtracting for this part. So make sure you're watching your signs.
Okay.
All right, so to finish this, I have y squared minus 5. That's x minus 2 squared equals 30. Everyone agree? And then our hyperbola equation is like an ellipse equation, so it has to equal 1 at the end.
But if it's negative 20, why would you not add it?
I have negative 20, so I have to put negative 20 on the other side.
Oh, because it's kind of showing everything.
Because technically that's what I'm adding to the left-hand side. It just doesn't look like that. All right, so I get y squared over 30 minus x minus 2 squared over 6 equals 1. If you had to go through and find the foci and the vertices and all the asymptotes, this one would have a lot of square roots in it, because obviously the square root of 30 and the square root of 6 aren't nice, perfect squares. But again, you should be able to at least rewrite them.
Yeah.
Questions about how to rewrite them? It's the same as ellipses. You should make sure you really watch your signs.
30. Also,